Okay, I'm about to share my screen, and then from there, we are going to officially start with our lesson for today. So let's see. Is it clear there, Langelihle? Can you see?
Yes, I can see.
Okay, 100%. Something that you should be aware of, Langelihle, is that based on the work that I've given you, it really shows that you are improving, a honorable member, because the problems that I gave you, I wasn't expecting you to get them correct. So with you getting them correct, it is a good indication that we are definitely getting somewhere. So something that we need to work on is to make sure that we master the newly introduced laws, or the laws that I introduced on our last lesson. So let me quickly open that study guide, and then from there, okay, this is the one for grade 9. And let me go to the table of contents, exponents. Yes. Okay, it's law number 3, the one that you are still struggling with. Okay, not that you are struggling with this law, language. The issue is that you forget the first step of applying this law. So let's see, law number 3, we said, let's say law number 3, which indicates that inside the brackets, if you've got base a to the exponent m, you close, you have n on the outside. Maybe let's start here, Langelihle. I think what you need to be aware of is understanding the meaning of the brackets. Maybe you tell me, Langelihle, based on what you know or what you can remember, what does the brackets mean in mathematics?
Two times is what's next to it.
Yeah, so at all the times, the brackets needs to remind us of multiplying. But because here we are dealing with the laws of exponents, then it will mean we are going to multiply those exponents. So the mistake that you do, it is to say a to the exponent m, and then we have n on the outside. What you do is to say n, you take that m, you plus it with n. And this one of plussing is law 1, which says you plus the exponents only if the bases were the same. But in this case, you only have one base to the exponent that, and then on the outside you have that. All that you need to do, it is to say a, you have m, that you must multiply by n. That's how law 3 operates. Can you see a Langley?
Yes,
A Langley, are
I can
you
see.
still there?
Yes, I'm still here.
Yes, okay. So let's quickly check. Let's quickly check. I'm just checking if I can give you, or otherwise, if not giving, but something that I can quickly work out to apply these laws, just so that as soon as we are done with this law, we introduce another law. Let's see. Okay, it's fine. Maybe let me do these problems. Let me do these problems. The one that you got wrong, you will then redo that one. But on my side, maybe let me do this one and say, we are having, let's say, inside the brackets is a to the 2, and then Okay, Langelihle, I did notice what happened. So, yeah, the power went off on my side and I was using a Wi-Fi. So it was connected to a power bank, but now looks like the power bank depleted, so I had to do a hotspot. But let's see, can you see on my screen? Can you hear me?
Yes, I can.
Okay, then it's fine. So what I'm going to do, it is to try work out these two problems being A and B. So let me start with problem A. So what you need to remember is that the base is that one being A, so that exponent you multiply it with that one inside and also that one. So that means you will have 2 that you must multiply it by 5. That is the first part. And then you'll be having that 3 that you must also multiply it by 5. So you end up having a to the exponent 10. And then here you have b to the exponent 50. That is how you would work it out. Langelihle. Any questions on this one, or is it clear?
It's clear.
100%. So now let's look at this other question. So when it comes to this one, Langelihle, you just need to be aware that we have that as a coefficient, we have the base, and then their exponent. So how this one, you should work it out is having that -2, and then you are having 3 on the outside, and then you are having x, which is to the invisible 1 that you must multiply by 3, and then here you've got y, which has an exponent of 2 that you multiply by 3. And then this is equals to, so this one, Langelihle, don't stress that much. You just punch it on your calculator. As inside the brackets, you have -2 to the 3. You might find that it gives you 8. X to the that times that is 3, and then y to the that by that it gives you 6, and you'll find that this is the end of it. Did it make sense, Langley?
Yes, it makes sense.
Okay, now I want to prove something, Langley, to show you that it's not difficult to make a mistake when it comes to mathematics. Did you notice that this one, I just said you punch it on a calculator, but I did not punch it on a calculator. Did you notice, Langley?
Yes, I noticed.
Yeah, so punch it on a calculator and check if indeed it gives 8 or if it gives something else.
Yes, it does. It gives negative
Gives
negative
negative
8.
8 and not positive 8. Can you see? So that means what I did there, it was wrong. And the reason to that is because um, I trusted my head and not the calculator. The calculator will always be right as long as you punch it correctly. So that means, Langelihle, when it comes to the numbers, just make sure that you use calculator, especially when negatives are involved. Do not just say because I know 2 to the 3 is 8. Therefore, you rush to write 8 there. Punch it on a calculator and be sure of what it gives you. Make sense, Langley?
Yes, it makes sense.
100%. So now let me create an example of my own so that you will notice something. Let us say inside the brackets we have -x to the 2, and then we have y, and then we have 2. So can you see this question, Langley? So here you must just be aware that no, let me make it 3 and not 2 there, Langelihle, there, let's make it 3. So what I wanted to say was, we have invisible 1 there. Do you agree?
Yes, I agree.
So that means when it comes to this one, we will have inside the brackets -1 close to the 3. Then only after you can say x 2 that you multiplied by 3, and then you are having y invisible 1 that you must multiply by 3. And this should be equals to, and then now, this is where that one Langelihle, you need to punch it in a calculator and not write it just like I did on the previous question. So what does it give you when you punch it on your calculator?
Gives me -1.
Yes, then it means you write -1, and then you are having x to the 6 on that one, y to the 3. Then you can still rewrite it as negative invisible 1, x to the that to the 6, and then y to the 3. Then this is the end of it, Langelihle. Did it make sense, Langelihle?
Yes, it made sense.
100%. So you see, the 2 problems that you sent today as corrections, very quickly work them out and then send them again via WhatsApp inbox. Do you have a phone with you?
Yes,
Okay, then it's fine. Very quickly do them both and follow this process that I was going through, where you nicely work them out. If there is a negative number inside the brackets, and then whatever power, and then you follow the letters, and then you simplify until the final answer. I will just give you a maximum of 5 minutes on that one. You know which problems to work on most, Langley?
yes, I know.
Okay, then it's fine. I'll be waiting in the meantime. So you'll send them via WhatsApp inbox as soon as you're done. Then let me know after sending. I'm going to be writing some things there, Langelihle. I'm just hoping that you won't need what I've written. So I just want to write a law and some examples that we're going to be working on. Okay. Langelihle, are you still working on it?
Yes, I'm still doing it.
Okay, then it's fine. On my side, I'm done with what I wanted to do. We'll just wait until you are done working on it. Langelihle, are you still working on it? Langelihle, are you still
Yes, I'm still
there?
working on it.
Okay.
I'm done now.
Okay, then it's fine. I think what you can do is to send via WhatsApp. Okay, you can send via WhatsApp inbox and then I'll check.
I sent you the picture.
Okay, let me download. Okay, let's see. Um, multiply out of that, out of that, and out. Okay, then it's fine. I'm also going to redo them. Um, then I would like for you to have a look at how I go through each variable. So let's see, we have negative b squared multiplying. We have a and then we have b to the 3 that you must close, and that is multiplying negative b to the 3 and then that and then that. Okay, maybe let me start with this one, Langelihle. So the best thing to do is to just remember that, you see, that one of negative, it's going to give us problems. So let's rather make it a invisible one there. So now, then it means we are only concentrating on where we are having the brackets. Anything else, we write it as it is. So this is negative invisible 1b. We have a squared there. So you see this one, Langelihle, a mistake that you made on that one is to exclude that a over there. And I think it was not fair of me to give you, especially these two problems. The reason to that is because the law that you need to apply is law number 4, but it's fine. let's continue. One thing for sure, you will understand, even though you may not have confidently, not necessarily confidently, because you haven't been taken through this law. So look at this Langelihle. You see that it is to the exponent of invisible 1. Do you agree? So that 2, it multiplies that 1 over there. And again, it multiplies that 3 over there. And then we have that invisible -1 that you must say inside the brackets. You have that -1, you must square it. And then you have that b, where you say that 3, you multiply it by that. Can you see what I've done there, Langelihle?
Yes, I can see.
Yes, but does it make sense? Do you understand?
Yes, I understand.
Okay, so now let's see. That means we still have our negative b squared, where we multiply our a to the exponent of 2, and then we have our b to the exponent of 6. Okay, so what will that be, Langelihle? -1 inside the bracket squared, what will that be?
It'll be +2. You know, +1.
+1. So it will just be positive invisible 1, and then we have b to the exponent. That by that, it becomes a 6 also. There it's 6. Also there it's 6. So that step, Langelihle, did you understand it?
Yes, I understand.
Yeah, so now we can rewrite it nicely and say, okay, you see that negative Langelihle, we can always leave it on the outside. If you have a negative, you just leave it on the outside, and then you say you have a squared multiplying, you have b to the 2, you have b to the 6, you have b to the 6. Then you have negative a squared, you have b. Can you see? Now you have the same basis of b. Then you add their exponents. And then that, then you will see you have negative a squared, b, that is 12, 13, 14. And then you can see you have 14. Then this could be the end of it, a Langelihle. Does it make sense there, honorable member?
Yes, it makes sense.
100%. So let's see that other one. Okay, it's fine. We can still look into that. So do not worry that much about these questions, Langelihle. I did wanted to give you something a bit more difficult, even though it's not something that I've taken you through. The reason for that, Langelihle, is to make you aware that it's not at all the times where you'll be faced with everything that you've done in an exam. Sometimes you will come across some questions which you haven't gone through before. So in that case, you need to apply your mind, meaning whatever that you've learned on other topics, you need to try and apply whatever that you know. So that was the purpose of me giving you such problems. So this other one, it was negative. What was there? Let me quickly check what that question was. Into negative. This is negative x to the 3, 2 to the 3. It's like this, Langelihle, isn't it? Langelihle, is it like this?
Yes, that's the sum.
Yes, I just copied it from what you wrote. Okay, so you see there we have that invisible, a negative invisible one. And then something that you should be aware of, a Langelihle, is that what is 2 to the 3? Do we know 2 to the 3 in terms of a number?
Yes.
Okay, what is that number, 2 to the 3?
8.
100%, it is 8. Yes, you must always punch it on a calculator to know. Okay, so we have -1 that you put inside the brackets. And then you see there we also have a -1. So then we must put it inside the brackets and say -1 to the 8. And then we have x 3 that we must multiply it by 8. That step, a Langelihle, does it make sense, or did I lose you somewhere on that step?
Makes sense.
Makes sense. Okay. So we have our negative invisible 1 multiplied by, what will that be, a Langelihle, when you punch it on your calculator?
That'll be +1.
+1. Okay, so that means we have -1 that multiplies with +1, and then we have x to the, what is that by that? 30 minus 6 is 28. Is it 28? No, not 24. I think it's 24. Then you have -1 that multiplies 1. It gives you -1. And then you have x to the 24, which is the same as -x to the 24. This should be the end of it. Does it make sense what I've done there, Langelihle?
Yes, it makes sense.
Yes, okay, then it's fine. So what I'm going to do now, it is to introduce law number uh, law number 4. I want to introduce law number 4, and then from there we will look into those problems. A very simple law, Langelihle, which says you have different bases inside the brackets. All that you need to do, this exponent outside will multiply the exponent of that base and the exponent of that base. All that you need to remember is that the brackets means you must just multiply. So now we have that base. We know its power, it's invisible 1, that you multiply by that outside exponent. And also there you have a base with its exponent being invisible 1, that you multiply by that outside exponent n. So that's why you end up having that being law number 4, as we multiply the outside exponent by the inside exponent of every base. It doesn't matter if inside we have a, b, c, d. You will just say a to the 1 times n, b to the 1 times n, c to the 1 times n, d to the 1 times n. Even if it starts with a number, it will be a number to the n. Even if it's a negative number to the n, obviously that will be inside the brackets, meaning open negative number close to the n times a to the 1 by n, b to the that. You will probably understand this better as I solve those problems, Langelihle. So let's see. Any questions with that law, Langelihle, or are you ready to start going through those problems from A to D?
I think I'm ready to go to the problems.
Okay. And let me quickly rewrite that first one being A. That is 2x to the 5. What is that? That is negative 3. Negative 3x to the 3. We have y that you close that. Okay. So let's see. Langelihle, maybe let me give you a chance to have a look at that and give it a try. What do you think the first step is going to be? You can just say, and I'm just going to be writing there.
So I must tell you now what you should write.
Yes, you can tell me what to write, or and it's either you're also trying to write it on your side, or by just looking at that, you can tell me what to write.
Like, so I should tell what to write now or is an option.
Say again.
So is it fine if I tell you what to write now before I do it on a piece of paper?
Yes, no, it's fine. You can tell me what to write.
You can write 2x to the power of 5
Mm-hmm.
bracket negative 3x to the power of 3.
You said negative 3x.
Yes, to the power of 3.
Wait, what did I do? Okay, that, yes.
Then next you write, you close bracket. Wait, no, you don't close bracket. Wait. Okay, yeah, next you write y to the power of 2. Y to the power of 2 in the same bracket, close bracket.
Okay.
Then next you write negative. Oh, wait, I made a mistake for the first one.
Okay.
For the exponent, you're supposed to say times 2, yes, times 2.
Okay, maybe let me do this. Okay, let's start it from here. What am I going to write?
Open bracket negative x to the power of 3 minus times 2.
Wait, so I open bracket and I write negative x.
Yes.
Okay, negative x. Mm-hmm.
No, negative 3x.
Okay. Negative 3x. Okay.
Then 2, 3 to the power of 3 times 2. Then next write y to the power of 2. Close bracket. Next you write 2. Yeah, yes. Next you write negative 6. Negative 6 x to the power of 5 times 6.
Item 6.
Then next you write y to the power of 2.
Okay. So that means You will see negative 6x. What will that be? Is it 30 there? Huh?
Asking me.
Yes, I mean,
30.
5 times 6 is it 30?
This is 30.
Okay. Uh, okay, then it's fine. It's fine, it's fine, it's fine. Okay, let's redo it, Langelihle. I just want to show you something very much important. Not a bad attempt, not a bad attempt. So I want you to notice the risks of taking a shortcut. Let's see. So look at how I'm going to do it, Langelihle. So on the first step, I want to remove this bracket. So that means whatever that I do, I no longer want to write the brackets again. So this one already it's not inside the brackets. I'll just rewrite it as it is. So law number 4, Langelihle, what it says is that this exponent, it must multiply everything. So it must multiply that, it must multiply that, it must multiply that. Can you see, Langley?
I can see.
So your mistake was to not multiply this on its own, because this is a number on its own. And then even with the x, you therefore need to say that times that, which is what you did. And then with the y, rather show it and say 1 times 2 and not write it as 2. Can you see what I've done there, Langley?
Yes, I can see.
Yes, then now you can maybe group them, or if you don't group, you can just multiply. Let's maybe multiply for now, meaning 2x to the 5. What will that be? That one of negative 3 squared, what will that be?
Negative 3 squared will be, won't it be positive 9?
So that means we have positive 9 multiplying x. What is that by that? That is 6. And what is that by that? That is 2. So that means you have that times that. Can you see that one, Langley?
I can see.
And then you have x to the 5, that you bring it closer to x to the 5. And then you have y squared, just to rearrange them in that order. Makes sense there, Langley?
Yes, it makes sense.
Yes, that by that is 18. Do you agree?
Yes, I
And
agree.
then law 1 says when you multiply the same basis, what do you do to the exponents?
Asking me.
Yeah, so you add the exponents. You remember that law 1?
Yes, I remember.
Yes, then this one, it has its own base. So that means you end up having 18x to the 10 and then y squared. It looks like this is the end of it, Langelihle. Maybe have a quick look on that one, Langelihle, and let me know if you can understand what I've done there.
Mm.
Uh-huh. Langelihle, does it make sense? But wait, it looks like I made a mistake somewhere. I don't know if you noticed, Langelihle. There
Yes,
it's
I can
supposed
see.
to be 6 and not 5. Can you see?
Yes, I can see.
Yeah, so that means it's not 10 there, it is 11. So if you make such a mistake, Langelihle, rather cancel all of this, because in mathematics, we don't want a situation where you scratch something and then you write something over something, just like I did there. It just makes it to look not neat. Let's say it's not neat. So rather redo it completely. So are you sure, Langelihle, you understood everything on that question? And did you also notice your mistakes?
Yes, I noticed my mistakes.
100%. So now let us try that second one. So you can already see how your homework is going to look like. So let's see. Then we are going to do that one of B, where inside the brackets we have -2y to the 3 close that of that. We have 4xy that. This is multiplying. So what you should just be aware of here, Langelihle, is that things are getting tougher now. We are combining the laws. You'll find that you apply law 1, all of a sudden you're applying law 2, and then Jiki Jiki's law 3, all of a sudden is law 4. So it's like you are now applying all the laws in one problem. So that's how difficult it can get. But we still have a long way to go, Langelihle. We are not going to continue until we master this law, because the maths problems that you can think of in the coming grades, including the current grade that you are in, it's all about applying these laws, Langelihle, and also it's all about you understanding how they solved certain problems, because they do apply these laws. So you'll find that in grade 8 they taught you about these laws, but if you forget, then it becomes a problem, because in grade 9 they no longer teach the laws, but they apply the laws when they solve the problems. So maybe let me give you a few minutes to work on the first step. And then I just want to quickly grab a glass of water, and then from there I'll come back and we'll discuss the first step. So for now, work on the first step, Langelihle. Are you ready there?
Yes, I'm ready. I think I'm ready.
Okay, very quickly work on it. I'll be back in less than a minute. Then we'll continue.
Ya kgolo mo gae mo ke beile dilo tse mo apea na kgolo na wena o berekisa
Langelihle, ngibuyile much. Let's now have a look at your first step, because the first step, it is the most important one. You get it wrong, everything going down is wrong, or you won't get 100%. So let's see. What will be the first step, Langelihle? What am I writing?
I'm just confused a little bit about what I have to do. I just want to ask, what do I have to start with? Because I see it's just a whole fraction. I want to ask, should I do both of them at the same time or start with them piece by piece?
So my advice would be, the first step is always to start where there are brackets. It doesn't matter the type of maths problem you're dealing with. You always start where there are brackets. Then after removing the brackets, then that's when you will group the like terms, like the bases, put the ones for the x as the bases close to each other, the y close to each other, then you will see which law to apply. Are you answered, Langelihle?
Wait, may please repeat?
So I was saying, you always start where there are brackets. So it's like in maths, if you are confused and you don't know where to start, you always start where there are brackets. Anything else, if it's not inside the brackets or if it does not have the brackets, you just leave it as it is for now and only work on the brackets. Then after, next step, you will deal with the like terms.
Yes, I'm answered now.
Still confused?
No, I'm answered now.
Okay, then it's fine. Okay, so in my presence, you can let me know where are we going to start? And what am I writing?
You just give me a moment. I want to think over something.
Okay. Let's see, Langelihle, are you still there?
Yes, I'm still here. It's just I made a mistake by the start. I have to redo it.
But are you done with the first step or are you still working on the first step?
I'm gonna have to restart it, so I'm doing it right now.
Okay, now I see. So it's only the first step. So you won't need to do it until the end, just the first step. As soon as you're done, then you can let me know.
Yeah.
Let's see. Um, are you still working on that first step, Langelihle?
Yes, I'm almost done. I can see progress.
Okay, then it's fine. You will let me know once you are done.
Yeah, sorry for taking long. Just my calculator isn't working. You know?
Okay. What's wrong with the calculator, Langelihle?
You see, normally when I press the on button, it doesn't wanna go on. But sometimes after a while it goes on.
I see. Okay, then it's fine. You will just let me know once you are done.
Okay.
Let's see. Langelihle, are you still having a challenge with the calculator?
Yes, I think I'm done now.
Okay, then it's fine. What did you do on your first step?
Okay, the first thing I wrote was I wrote negative 8 x to the power of 3 y to the power of 9 over
Wait, you say, what am I writing?
first first you write negative 8 x to the power of 3 y to the power of 9.
Okay.
Then next you write for the denominator you write 8x to the power of 2 and y to the power of 12.
Okay, 8x to the power of
12.
12. Okay.
Yeah, continue.
Yes, we can continue. 8x to the power of 12. Okay.
Then next I calculated it writing negative 8. You see, I completed the sums already, so just calculated negative 8 divided by 8, x to the power of 3 minus 2, and y 9 minus 12. Then I wrote as my final answer 1x and y to the power of 3.
Uh, Wait, so what am I writing here? You see there, I wrote 8x to the 12. What am I writing next?
Can you please repeat?
So do I write something there, or that one is done?
Yes, you write something there. You write y to the power of 12.
Y to the power of 12. Okay. Maybe let us start here because I see you've done it correctly somewhere, but you took shortcuts. And I want you to avoid taking shortcuts so that it's as if you are explaining to someone in primary. Let's maybe start here. How did you get negative 8 squared?
Negative 8 squared.
Not negative 8 squared, but negative 8. Yes. How did you get negative 8?
By timesing 2 times 3, 2 to the power of 3, putting that.
Uh, okay, even though it's correct, Langley, even though it's correct, but I want you to write it like that. Makes sense, Langley?
Yes, makes sense. So I should write them in separate
Yes.
brackets.
Mm-hmm.
Okay, you see, before I do that,
Mm.
to the power of 3 outside, should I put the negative 2, then the x in different brackets, or all in the same brackets still?
Okay, no, I see. So you don't put them inside the bracket. So you're going to say, in removing the brackets, how many bases do you have inside the brackets? You have 1, 2, 3. You have 3 bases. Can you see? So
Yes.
this one, because it has a negative, that's why you put it inside the brackets. Then this one of x, you no longer put it inside the brackets. You must write it as 1 times 3. That's how you must write it. Then this one of y, 3 times 3. Can you see, Langley?
You can see.
Yes, but if it was 2xy to the 3, and let's say it was like, you see, that base, it's positive 2. Can you see, Langley?
Yes, I can see.
Because it is positive, you don't need to put inside the brackets. You can just say 3. No, no. 2 to the 3 x 1 times 3 y 3 times 3. So the reason why that one you put inside the brackets alone is because it has a negative. But if it doesn't, no need to put inside the brackets, because the main aim on your first step is to remove the brackets. So that's why you can't still have the brackets there. Does it make sense, Langley?
Yes, yes, it makes sense.
Yes. Your question is a good one, because that is the most confusing part. But once you understand that one, then you should be fine. So can you see when I say don't skip steps, but do it step by step? That one at the top is 100% correct, even though you took shortcuts on that one. But now you know how I want you to write it, nay?
I think that's your question.
So I was saying, you now know how I want you to write it without taking shortcuts, nay?
Yes, yes.
Yes, okay. So now let's look at that one at the bottom. So that one at the bottom, how did you get that 8?
By timesing 4 by 2.
So that means you must first write it as 4 times 2 before you write it 8. So that whoever is marking your script, they can see where the 8 is coming from. Otherwise, it will look like you were copying someone next door if you don't show where the 8 is coming from. Can you see? Yes, okay. Now let's talk. Where is the x to the exponent 12 come from? Where does it come from?
12. No, it's 2.
Eh?
I wrote 2 by my notes.
Okay, it's fine. Let me update it, then you will tell me where it is coming from. Let's see. So you say 2 there. Okay.
Yeah. I just multiplied the invisible one from the exponent by the left and the 2 from the right.
Let's see. Because you see that part of the denominator, we don't have the brackets there, isn't it?
Yes, you don't.
Yeah. So if we don't have the brackets, you group them as like terms. So that means this one, you group it with that one. This, you group it with that one. Meaning you have 4 times 2, you have x to the 1, you group it with x to the 2, you have y to the 4, you group it with y to the 5. Can you see a Langelihle?
Yes, I can see.
Yeah, so that means there, you don't multiply because we don't have brackets on the denominator. So if you don't have brackets, you don't multiply the exponents. You only multiply the exponents if you have those brackets there. But if you don't have the brackets, you group them together and you apply a different law. Can you see?
Yes, I can see.
Yeah. So which law are you going to apply in that case?
I don't
Or
know.
even if you don't remember the law, but how are you going to work it out? Difficult, nay.
No, by adding them together.
Okay. What will it be?
If you add them, the answer will be 8x to the power of 3, y to the power of 9.
Yes, 100%. Exactly that. Exactly that. So can you see? So every time when you have that fraction, take it as this, you work it out as if you were given that alone. Then you do this one as if you were given that alone. Then once you have a worked out numerator and a worked out denominator, check if you have the bases which are the same there and there. Then you will apply that law of saying that exponent minusing that exponent, or maybe that exponent minusing that, or that exponent minus, depending on the basis, if they are the same. Remember that law which says if you are dividing the same basis, you subtract their exponents. Do you still remember that law, Langley?
Yes, I remember.
Yes. And then that should be how you work it out, Langley. So I think for now, this will be the end of it, and I will give you some problems to work on in the coming week. Unless if you've got any question, Langelihle, but what I'm going to do, I will save this and send to you both the notes and the recording so that you can refer. So you tell me, Langelihle, any questions from your side?
No, I don't have a question.
No question, but can you see, Langelihle, that it's just a confusion of the application of the laws. It's not like there's something that you don't understand there. Do you agree?
Yes, I agree.
Yeah, so that's it when it comes to maths, Langelihle. If you've got someone who's training you, someone like myself, I'm training you on these things and you understand everything. When we say maths needs practice, that's what we mean. So you just have to redo the same thing over and over and over again. Trust me, Langelihle, once you master these laws, even when you are given something complicated, you'll always know where to start, what to do, where you get confused. If someone explains to you, you will understand better than everyone who's not practicing, because you know how the law works. And even if they say, this is what I'm going to do, without them having to say, I'm applying law 4, you will already know that, okay, mathematically that is possible. If we want to trace where or what guided them to do what they did, it can be traced back to one of those laws. So when we say maths needs practice, that's what we mean, language. You just need to do these things over and over and over and over again. That's it. Because one thing for sure, you do understand everything that I'm explaining. If I give you a problem and you get it wrong, it's not because it's complicated, or it's not because you've got no idea of what needs to be done. It's just a confusion of laws of application. So before you can do the exercises that I'm going to give you, best thing to do is to redo what we have already done. Check if you can do it correctly. And then every time before you work out a problem, ask yourself, which law am I applying? And then based on that, if you can be able to answer your question of which law am I applying, then whatever that you do, you'll be guided by the laws. If you do something and you don't know the law that you're applying, then you can easily make mistakes, because you are doing something that you are not guided by the laws. And you've already noticed that all that we are doing here is to apply the laws. Make sense, Langley?
Yes, it makes sense. May I please just ask, can I go? I really want to use the restroom.
Yes, no, then it's fine. We are done. I will forward you everything. And then, yes, no, then it's fine, Langley, until we meet again.
Okay.
Okay.